Alright, I have two iPhone 6 Pluses here. This one I'm doing data recovery on, and you see it's bad backlight. This one is a good working one. Backlight is perfect with it. Okay, no problems. So I'm going to show you guys how to kind of test it a little bit to find out which line it is. So on the iPhone 6 Plus, there's two backlight circuits. Let me go to ZXW real quick. Alright, so the iPhone 6 Plus has two backlight circuits. There's U1502 is the backlight IC, and U1580 is the other backlight IC. They're similar, but they produce a different voltage at the anode connection of the backlight circuit. Okay, so basically, let me see if I can bring up a schematics here, show you guys. Alright, so this is chestnut. Let's see if I can bring up the backlight circuit. I think it's in the same area. Okay, so you get the backlight driver here, okay? So this is how the backlight system works on the 6 Plus and pretty much every iPhone out there. So the main incoming input voltage is PPVCC main, which is either going to be the battery or the USB connection. When the USB plug is connected, then it's going to go off USB, and that's going to usually be around 4.2 volts. If it's on battery, then it's going to be right around 3.8 volts. Maybe a little higher depending on what the battery voltage is. Okay, so input voltage, it feeds this inductor here, which boosts the voltage. Okay, so since the 6 Plus has two different circuits, all right, let's see, I believe one goes at, I think maybe the coil is a little different in the other circuit, which is why the voltages are different. Anyways, let me see if I want to go through this whole thing or not. Alright, so let's see. Okay, so VCC main comes in at whatever, roughly 4 volts. Inductor boosts it to about either 11 volts or 17 volts, okay, depending on the rating of the inductor. Okay, so basically, if you know Ohm's law, it says that current is directly proportional to voltage. But when you have a current limiting element here, like such as an inductor, then it's going to boost the voltage, right? Less current, more voltage. More current, less voltage. Okay, so 4 volts turns into 11 or 17 volts or 20 volts, depending on which iPhone it is and what the rating of the inductor is. Okay, so boom, boost it up here. Okay, but here's the thing. There's a diode here. Okay, and this diode acts as a switch. Whether to let this boosted voltage go through this circuit or not. Okay, and so when this diode is on, then it releases the boosted voltage to this anode line right here. Alright? Which, you know, this anode line connects to a filter, and then the filter goes to the connector. Connector powers the backlight. Alright? So, what prevents the boosted voltage from coming through, right? Well, there's a switch here on the backlight IC, U1502. Alright? So this switch basically opens and closes. When this switch closes, right? When the switch closes, the voltage going across the anode side of the diode goes straight to ground, which essentially makes the voltage across this point right here to ground whatever the VCC main voltage is, which is going to be between 3.8 and 4.2 volts. Okay, so when this voltage is between 3.8 and 4.2, it's going to be the same as the cathode side of the diode, which means that this diode here basically just it flips to the off position. Okay, because in order for a diode to work, the voltage on the anode side has to be greater than the voltage on the cathode side. And depending on the type of diode, I've always been taught right around 0.7 volts. All right, it's got to be a 0.7 volt difference in order for the diode to be in the on position. Okay, I think this one's rated. I think Mark had said it was rated at 0.37 volts. All right, so it's all going to depend on what kind of diode it is, what it's made out of, and stuff like that. You can go to DigiKey and look up this number right here, and you'll be able to see the exact specifications of this diode. Okay, but essentially, diode goes to on when the voltage is greater on the left side than it is on the right side, anode side, cathode side. Okay, so that's what enables the boosted voltage. Backlight IC handles that, right? So boosted voltage goes over, produces a greater voltage at the anode side to light the backlight. Okay. All right. I don't know if you guys got all that or not, but it's kind of complicated. And then you have some other things here as well. You have two cat lines, which are generally things like 0.2, 0.3 volts or something like that. I'm not even exactly sure what they do, but they probably power different parts of the screen. And then you have some other lines here. I think this is a clock, and I'm not exactly sure what that is. But anyways, let's just leave those out for now. Okay. The big one is really the anode line. You just have to, because that's the one that usually blows since there's a high voltage come through it. All right. So let's minimize this, and let's go to the schematics here. So you have the iPhone 6 schematics right here, and you have two test points here. Okay. This is one. So this is PPLCM BL34 anode connection, and then you got this one, which is the anode connection. So those are the two outputs of the two backlight systems on 6 Plus. Okay. So how do you find out which backlight system it is that's messed up, right? Well, all right. So we're gonna actually go to the phones now. Okay, with under my scope here. So screen is on. I just changed the setting to never disable. Okay. So the screen has to be on in order for you to test the backlight voltages. Well, it technically doesn't have to be on, but it has to be connected when you boot up in order for the voltages to appear, for the boosted voltages to appear, because, well, I'm not going to get into that right now. Alright, so these are the two test points we have. This is the anode connection, this is the other anode connection of the two. So basically, these are the two outputs of the backlight system, okay? So this is the bad phone. So basically, I'm just going to touch one lead in voltage mode. I'm going to touch DC voltage mode. I'm going to touch one lead ground, and that'll lead to the to this point right here, okay, which is going to give me the voltage across the anode line. Okay, so this one shows 11.4 volts. It says negative 11.4 volts, and does it really matter if my black lead is on ground or red leads are? No, it doesn't really matter because I can just switch it right now, and it's going to give me a positive voltage. All right, so the only thing you really care about is the actual voltage. The only thing. So it doesn't really matter which lead you put where. Okay, the colors and stuff like that. Okay, now I'm going to test the anode, the other anode connection. Okay, so this one's giving me 3.8 volts. All right, which is essentially telling me that the boosted voltage is not getting through to this side for some reason. Right. So, which is why I have a dark screen at the top right of the screen. Okay, so that's kind of how you determine. And I'm going to go to my working phone now, and so here's my working phone here. This is a full backlight, no problems, and I'm going to test the voltages again. So this one, this one's 11.4 volts. This one's 17 volts. Okay, so on a known good working phone, the voltage should be for 6 Plus. So on a known good working phone, the voltage at this point should be right around 11.3 volts, and this one should be right around 17 volts. All right. So if you're not getting that, that means something is wrong within that circuit. Okay. So now that we've isolated which backlight circuit it is, now we can go back and trace it now. Okay. So this is the filter that leads into the this is the filter that leads into the to the connector. Okay, so we can just trace it backwards. All right. So the filter, we know that it connects to this capacitor right here and this diode, and this is the IC that had the problem. Alright, so okay, so here's what we're gonna do now. Alright, I'm gonna alright, so this is the bad screen right here. And let me go back to my other. Okay, so we tested this point right here. This is the backlight. This is the side, the system that is messed up. Alright, so that's the side we're going to trace. Right? So the phone is still powered on right now, and you really don't want to measure anything when the phone is powered on. Right? I mean, you really just want to measure voltages. Okay. So let's turn the phone off. Okay, let's just disconnect it. And let's just go through our checks real quick. So I'm going to change the multimeter to continuity mode, diode mode. Alright, and let's measure some of the filters first. Okay, so I don't even remember which filter it was now. I think it was. Okay, so this is the filter right here that connects to this. Okay, and you can check, see if this is good, and it is. There's continuity across this filter. Okay, you can also go to resistance mode here and check the resistance across the filter, which you know, so long as it's within specs. I'm getting 0.8 ohms, which looks right. So we know that the connection from here to the filter is fine. This cap's not shorted, and so now we trace it back to this capacitor right here. Right? So essentially, we just want to make sure that this capacitor is not shorted, okay, or it doesn't have low resistance, which is not shorted, okay. So from this capacitor, we can go. Let's see. Okay, so from this capacitor right here, we go to this diode here. Okay, in order to test diode, you just put your diode into diode mode and measure across both sides. And this is when the positive and negative actually matters. Okay, so you should get 0.2, roughly 0.2 volts on one side, and OL going across it. Okay, which is what I'm getting. Okay, so from there I know that this diode is fine, so I'm not gonna have to replace that diode. Now, in order to test this, let's see. I can also test the coil. Okay. So basically, I don't know where the. Let me look. Okay. So just to recap, we went from this anode connection because we know that's the problem. We checked this filter right here, and if you look at the filter, it says 240 ohm, 0.2 amps, 0.8 ohms. Okay. So we know that, and we got 0.8 ohms across the filter. All right. So we know that the filter is fine. And then we check this capacitor for continuity, and there's no continuity, which means that this capacitor is not shorted, which is generally, when testing capacitors, you just check for short or open. Short is bad, open is good. Alright, so now we go to this diode. Alright, we want to make sure that diode is roughly 0.2 volts going one way and open going the other way, okay, which it is. Okay, so now from the diode we go to the coil. So in order to test the coil, you can put one lead on this diode lead, this side right here, and then the other lead on this side. Okay, generally, if you look at the rating of the coil, you're getting about 0.9 ohms. Okay, 0.9 ohms. All right, and so you can test the coil. If you're getting roughly 0.9 ohms, 1 ohm, something like that, then you can assume that coil is fine. Okay. And then you can also check these capacitors across it, and we'll go from there. Okay, so we're going to check this coil now. Alright, so we're going to put our multimeter into resistance mode, touch one lead right here, and then the other lead right here, okay? And let's see what resistance we get. We're getting 0.95 ohms, alright? So that is within the specs of this coil. So we're gonna assume that this coil is fine. Okay, so why are we still not getting 17 volts at this connector right here? I'm gonna assume that is probably the backlight IC because everything else looks pretty clean. I have run this through ultrasonic cleaner already, and there was noticeable gunk around here. It was water damage, so there's noticeable gunk around here. I imagine that something got corroded below the chip, so that's what we're going to do. Alright, we're going to replace the chip, see if that fixes the problem. And I mean, you know, this is really a data recovery job, but if I can fix it, I'm going to fix it. If it's going to take me way too much time to fix it, then I won't fix it, you know. But this is, it didn't take me very long to recover the data, so I'm going to go ahead and just fix this phone, hopefully, and have a happy customer, you know. Give them their money's worth. Alright, so I'm going to replace that backlight IC, and hopefully it'll work. I don't know if it'll work or not. Echo. Trigger soldering on. I'm gonna put a little flux down there just because I can't really tell what's going on right now. At least the flux, I can kind of see it bubbling a little bit, you know. Okay, so you can tell immediately that this chip right here, look at it. That pad right there is burnt. I mean, I imagine that that's probably where the water damage was. And I believe it was, let's see, I can't tell what the orientation is anymore of this chip, but probably that one right there. You can see it. So anyways, this chip is no good. That goes in the garbage pile. Sometimes I'll reball them, but looks like it's that pad right there that caused it. And my guess is that that pad is probably VCC made. Alright? Because it's usually the high voltage that gets jacked up like that. So we will put a new one on, and I'm pretty sure we should be good after that. I think I'm gonna maybe wick it. No, maybe I won't wick it. Alright, that looks pretty good. So let me get a new chip out, or yeah, let me get a new chip out. Forget it. I'm not gonna reball anything. Got so many of these chips everywhere. I believe this top pad right there is A1. Alright, so you just check the orientation of this thing, and A1 is the top. Looking at it from this direction is top left, alright? Alright, so I'll have my, I feel like I'm burning that right there, so let me get my coin back over here. Okay, so let's heat this up. I'm gonna direct the heat towards the coils, and I'm just gonna do it slowly, alright? Because I really don't want to heat anything else up, otherwise it's gonna cost me a lot of time. I'm gonna do that. I'm gonna be pretty careful here. And so in order to put these chips back, I like to hold it in place. I just want to make sure that I get it because I don't want to have to reball this later. Where the hell is it? That's not even right. Okay, it's like this. Phone call. Okay, so let's get back to this. So like I said, what I like doing is trying to hold it in place until at least part of the chip is kind of soldered onto the pads below. Okay, so that is pretty tight, I think. Yep, that's tight. So you can kind of nudge it, and it's pretty tight. So what I like to do is make sure that holds in place, and then just put some extra flux on it, and then I don't have to touch it anymore. I just kind of let it go, and just let the heat do its work, and it should kind of melt into place on itself and align itself. I'm going to move this a little bit. It doesn't seem like it's kind of, there you go. Alright, that should be fine, I think. Seems like a lot of heat though. And we can take it out. And we can kind of zoom in if we want. And just make sure those pads are fine. Should be 4 of them. I'm not even sure if I see that last pad connected. So, doesn't look like a great placement, to be honest with you. Let's see. Yeah, I don't see that last pad connected. So, I don't know what's going on with that. Pretty sure it should be 4 across, and not 3. Don't think it's going to work, to be honest with you. But before I take it off and redo it, so I can see it better on this side. It's weird. Is it 4 and 3? I thought it was 4 and... Okay, this is the back. Oh, it is 3. Okay, so we're good. Alright, so let's power it up. Let's clean it up a little bit with some IPA. And... Alright, so clean it up a little bit. And hopefully it works. Let's just do some simple tests real quick. Make sure this coil's not overheated. So I'm just going to do this and see what the resistance is. 1 ohm. Okay, that's fine. Alright, so let's see if it works now. Alright, so as you can see, we get full brightness now, and the backlight is good to go. I'm not going to show you the cover. So here you go, full backlight, and that is how you do it. Alright, so we are good to go now. I don't know about everything else, but I'm going to test everything, and this customer gets their data back, and they get hopefully a fully functional phone, because I think that's probably the only thing that was wrong with it. And we are good to go. So that's kind of how you diagnose and fix a backlight problem on an iPhone 6 Plus. Thanks for watching.